some of the important remote sensing satellites that operate in the optical regions of the electromagnetic spectrum. This includes ultraviolet, visible, near infrared, middle infrared, thermal infrared, wavelength ranging approximately 3 to 14 μm. There are many characteristics that describe any satellite remote sensing system. Satellites orbit including altitude, period, inclination and equatorial crossing time, repeat cycle, spatial resolution, spectral characteristics, radiometric properties are few of them. From 1957, when the Sputnik satellite was launched by Russia, to the present, a number of satellites have been launched by many countries. These satellites, launched under different space programs, carried with them sensors of different characteristics to gather relevant data about Earth. The data obtained by satellites have become increasingly important for predicting weather, studying hazards, monitoring global change and managing Earth resources space programs such as Landsat program, Spot satellite program, Radarsat, European satellite system, Japanese Earth resource satellites, Chinese National Space Agency, very high resolution systems such as Ikonos, Quickbird, OrbView. Space programs. A space program commonly includes space mission and their planning. A space mission is a journey of space by a manned or unmanned vehicle, that is a spacecraft or satellite, aiming to explore solar system and gather scientific data. A space mission program includes planning, designing and operation of specific space mission. The planning of a space mission is a complex and multidisciplinary task which includes various aspects of the mission from its definition to the end of the mission's life. According to the objectives of the space mission, they can be characterized into application, technology experiment and science and exploration. The first step into space was taken after World War II when Russia successfully launched the first artificial satellite Sputnik 1 into the space in October 1957. This marked the beginning of a remote sensing era as it provided first view of Earth's surface from the space. Subsequently, in the same year, the United States of America took a leap into the space age by launching its first satellite, Explorer 1, on 1st October 1958. United States of America established National Aeronautical and Space Administration (NASA) for space exploration. But the space age really began with the launch of Vostok 1 on 12th April 1961 by Russia. The space shuttle took Yuri Gagarin, a Russian cosmonaut, into space. Apart from USSR and USA, many countries of world, including India, have taken leap into the space exploration. Landsat satellite program. Landsat is the longest running program for acquiring satellite imageries of the Earth. First satellite in the series, Landsat 1, was launched in July 1972. It was a collaborative effort of NASA and the US Department of Interior. The program was earlier called Earth Resource Technology Satellite (ERTS) and was later on renamed as Landsat in 1975. The mission consisted of 8 satellites launched successively. The recent one in the series, the Landsat 8, which is also called Landsat Data Continuity Mission (LDCM), was launched in February 2013. Different types of sensors, for example, return beam Vedicom (RBV), multispectral scanner (MSS), thematic mapper, enhanced thematic mapper (ETM), the enhanced thematic mapper plus (ETM plus) have been used in various Landsat missions. Landsat missions use the sun synchronous near polar orbits at different altitude for each mission. Landsat satellites typically complete 14 orbits in a day. Landsat 4 and 5 maintain 8 days out of the phase, so that When both were operational, 8-day repeat coverage could be maintained. MSS used in the Landsat programs employs a cross-line scanning to generate two-dimensional image. Landsat 8 mission is inclusive of two sensors called Operational Land Imager (OLI) and Thermal Infrared Scanner (TIRS). The OLI is operational in 9 bands including one panchromatic band. The TIRS operates in 2 thermal bands. Data gathered by the Landsat have extensively been used by government, commercial, industrial and educational institutions over the globe. The changes in agricultural areas, deforestation, natural disaster, desertification, urbanization and degradation of water resources can be monitored with the Landsat data. Characteristics of Landsat sensor systems can be known. Spot satellite program. SPOT Systeme Pori Observation de la Terre was designed by Centre National d'Études Spatiales CNES, France as a commercially oriented Earth observation program. The first satellite of the mission, SPOT 1, was launched in February 1986. This was the first Earth observation satellite that used a line array of sensor and a push broom scanner techniques. Also, these were the first system to have pointable, steerable optics, enabling side-to-side off-nadir viewing capabilities. The recent satellite in the SPOT program, SPOT 6, was launched on September 2012. SPOT 1, 2 and 3 carried two identical high-resolution visible HRV imaging systems. Each HRVs were capable of operating either in panchromatic mode or in the MSS mode. HRVs used along track push broom scanning methods. Each HRV contained 4 CCD subarrays. A 6000 element subarray was used for recording in the panchromatic mode and the remaining 3 arrays each with 3000 elements were used for the MSS mode. Due to the off-nadir viewing capability, HRV was also used for stereoscopic imaging. Frequency with which the stereoscopic coverage can be obtained varies with the latitude. More frequent imaging is possible near the polar region compared to the equatorial region. SPOT 4 carried the high-resolution visible and infrared sensor HRVIR and the vegetation instrument VI. HRVIR also includes two identical sensors, both together capable of giving 120 km swath width at nadir. SPOT 5 carries two high-resolution geometric HRG instruments, a single high-resolution stereoscopic instrument HRS and a vegetation instrument. SPOT 6 mission employs two new AstroSat optical modular instrument, operates in 5 spectral bands including one panchromatic band. Pointable optics used in this program enables off-nadir viewing. This increases the frequency of viewing by 7 additional viewings at equator and 11 additional viewings at 45 degrees latitude. Due to the off-nadir viewing capabilities, stereo imaging is also possible. Stereo pairs used for relief perception and elevation plotting, digital elevation model, are formed from two spot images. Radarsat. Radarsat is the first sophisticated Earth observation satellite of Canada. It was built under the management of Canadian Space Agency in cooperation with provincial governments and private sector. Until now, 2 Radarsats have been launched. Radarsat 1 was launched in 1995 by NASA on a Delta II rocket. It was placed into a near-polar sun-synchronous orbit at an altitude of 798 kilometers above the Earth at an inclination of 98.6 degrees. It orbits Earth 14 times per day, in which each orbit takes 100.7 minutes to complete. Radarsat 1 has dawn-dusk orbit, which enables it to cross the equator at dawn and dusk, that is 6 am and 6 pm of local time. Further, this orbit keeps solar cell array of satellites in almost continuous sunlight and ensures satellite to rely on the solar energy rather than battery power. It is equipped with an advanced single C-band radar sensor SAR. Radarsat SAR is a powerful microwave instrument which transmits a microwave energy pulse in C-band having 5.3 GHz frequency to the Earth. SAR measures the amount of energy that is reflected back to the satellite from the Earth's surface. It has a wide variety of beam widths which can capture swaths from 45 to 500 kilometers with resolution from 8 to 100 meters and at incident angles from 10 to 60 degrees. Radarsat 1 is horizontally polarized, in which microwaves travel horizontal to the Earth's surface. The world's most advanced commercial C-band SAR satellite, Radarsat 2, was launched in 2007. It retains many specifications of Radarsat: left and right looking image options, superior data storage, and onboard GPS receivers for monitoring satellite position. Radarsat supply data to monitor environmental changes and natural resources of Earth at national as well as global level. It also provides important information in the field of agriculture, hydrology, cartography, forestry, oceanography, and coastal monitoring for both scientific and commercial uses. European remote sensing satellites. The European remote sensing satellite ERS is a European program for Earth observation sponsored by the European Space Agency. Under this program, two satellites, ERS-1 and ERS-2, have been designed and developed to observe oceans and its circulation, sea ice distribution, sea surface wind, and land areas with high resolution radar. ERS-1 was launched in July 1991. It is placed in sun-synchronous polar orbit at an altitude of 785 kilometers at an inclination of 98.5 degrees. It has a ground swath width of 100 kilometers. It is equipped with a comprehensive payload including an imaging C-band SAR, radar altimeter, wind scatterometer, along-track scanning radiometer, microwave sounder, and other powerful instruments to measure ocean surface temperature and winds at sea. During 1995, ERS-2 was launched, which represents a following on missions of ERS-1. ERS-2 is identical to ERS-1, but it is provided with an additional sensor to monitor atmospheric ozone levels. There is about 30 minutes time lag between ERS-1 and ERS-2 in the same orbital plane. As a consequence, a one-day interval between the ERS-1 and ERS-2 is observed on the same ground swath. Both ERS-1 and ERS-2 were operated in tandem from August 1995 to May 1996 to provide image pairs for SAR's interferometry research. In March 2000, ERS-1 satellite finally ended its operation, but ERS-2 is expected to continue operating for several more years. Japanese Earth Resource Satellite. National Space Development Agency (NASDA) of Japan launched the Japanese Earth Resource Satellite JERS-1 in 1992. JERS-1 FOYO-1 in Japanese is an advanced Earth observation satellite which is jointly developed by NASDA and the Ministry of International Trade and Industry MITI Japan. NASDA developed satellite bus while MITI developed JERS-1 gathered data on global land masses which have great application in the field of land survey, agriculture, forestry, fisheries, environmental management, disaster prevention, coastal surveillance, and for locating natural resources. Chinese National Space Agency. The China National Space Agency (CNSA) is arguably the fastest rising space agency in the world. Concurrent with China's economic miracle, the Chinese space program has grown considerably in the past 2 decades and has been mounting increasingly advanced and ambitious missions accordingly. Chinese government organization founded in 1993 to manage national space activities. The organization is composed of 4 departments: General Planning, System Engineering, Science and Technology, and Quality Control, and Foreign Affairs. China's space program evolved largely in secret under the joint control of the Chinese military and the Commission on Science, Technology and Industry for National Defense. China has developed a family of Chang'e Long March boosters which are used domestically and serve as competitors in the international commercial space launch market. Its space development has concentrated on applications such as communication satellites and Earth observation satellites for civilian and military use. China initiated its own space flight program in 1992. The spacecraft called Shenzhou, that is developed for the efforts, was modeled on Russia's time-tested Soyuz design, but it relied heavily on Chinese developed technologies and manufacturing. BDS is Baidu Navigation Satellite System, global navigation system constructed and operated independently by China. As a significant space infrastructure, the BDS provides all-time, all-weather and high-accuracy positioning, navigation and timing services to global users. Very high resolution system. Ikonos. Ikonos is a commercial high resolution system operated by GOI. The satellite was launched in September 1999. Ikonos was the first successful commercial satellite to collect sub-meter resolution images. Ikonos is in a sun-synchronous 681 km orbit with an inclination 98.1 degrees. The orbit provides daily access to regions within 45 degrees of nadir, 3-day revisit within 26 degrees of nadir and 141-day visit within 1 degree of nadir. The satellite provides imagery with spatial resolution of 1:1 meters in panchromatic band and 44 meters in multispectral band. 1 meter color imagery can be created by merging Ikonos panchromatic and multispectral imageries. In addition, the satellite has both cross-track and along-track sensors which allow it to acquire data flexibility having frequent revisit capabilities. Satellite collects data at a rate of over 2000 kilometers per meter. As a result, it has collected over 250 million kilometers square of imagery of Earth's surface digitally. High spatial resolution imagery collected by Ikonos is being largely used for national security, military mapping, earth resource management, air and marine transportation, and city and urban planning. Quickbird. Quickbird represents the first satellite in a constellation of sub-meter spacecraft that developed by Digital Globe. It offers a unique, highly accurate and commercially high-resolution imagery of Earth. It was launched on 18th October 2001 by Boeing Delta II launch vehicle into a 600 km orbit. It has a swath width of 20 to 40 kilometers. It offers images with 0.61 into 0.61 meters panchromatic and 2.44 into 2.44 meter multispectral spatial resolution. Its revisit time ranges from 1 to 5 days. It is the fourth satellite which obtained high resolution commercial imagery of Earth after Worldview 1, Worldview 2 and GeoEye 1. It has a greatest capability of onboard storage of data than any other satellites. It is capable of acquiring more than 75 million kilometers square of imagery data yearly and also allowing Digital Globe to update its image library at rapid speed. The satellite was launched in October 2001. Quickbird uses a relatively low orbit at an altitude of 450 kilometers. Payloads over the Quickbird include a panchromatic camera and a 4-band multispectral scanner. Quickbird sensors are composed of a linear array detectors to achieve a spatial resolution as fine as 0.61 meters in the panchromatic mode and 2.4 meters in the multispectral mode. The high quality satellite imagery of Quickbird is commonly used for map creation, change detection and image analysis. OrbView is another group of satellites belonging to GeoEye. 4 OrbView satellites have been launched by GeoEye. OrbView 1 was launched in April 1995. It is an atmosphere monitoring satellite that provided weather data to NASA. GeoEye launched OrbView 2 in August 1997. It provides the images of oceans which are useful for the study of global warming, commercial fishing, environmental and coastal monitoring. In the June 2003, the third satellite of the series, OrbView 3, was launched successfully. OrbView 4 was launched in September 2001, but this satellite failed to reach required orbit. OrbView 3 was designed to provide high-resolution imagery of the Earth. It was successfully launched on 26 June 2003. The satellite is equipped with a camera to take images with 1:1 meters in panchromatic and 4:4 meters in multispectral spatial resolution at a SWAT width of 8 kilometers. It is in a 470 kilometers sun synchronous orbit with an equatorial crossing time of 10:30 am. The sensor revisits location on the Earth is less than 3 days. OrbView 3 is the first commercial satellite to supply high-resolution imagery from space. Therefore, the imagery is collected by it can be used for environmental monitoring, construction planning, precise mapping and intelligence gathering. Advantages of space exploration. Space exploration can provide humanity with additional resources. Space travel may help us to find extraterrestrial life. We may find other planets to colonize. Humans are curious creatures and need to explore. Space exploration can offer almost endless opportunities. Many countries already notice the importance of space exploration. Technological progress will facilitate space travel. It has been the dream of many people to explore space. Also, private corporations can help with space exploration. We as humans recognize the relativity of life. Colonizing other planets may help to mitigate the overpopulation problem. Scientists from all over the world can work together. We can help us to install satellites, helpful to create maps and pictures. We can collect important research data. It may be helpful to us to detect serious threats to the Earth. Space travel may become available also to private persons. Space exploration may speed up technological progress. Space travel industry provides many job opportunities. It may help humanity not to go extinct in the far future. Disadvantages of space travel. Space travel implies significant air pollution. Particulate pollution can be a problem. Space exploration implies high levels of waste. Space exploration is quite costly. Many missions may not yield any results. Space travel can be dangerous. Space exploration is time consuming. Mental problems for astronauts. Problems with radiation. Space exploration may lead to a decisive advantage for few countries. May not be in line with a religious value. Extraterrestrial life forms may wipe out humanity. Summary. Remote sensing satellites which are being operated by various countries. Notably among them are IRS series, Cartosat and Radarsat of ISRO, India, Landsat of NASA and USGS USA, Spot of FSA France, Radarsat of CSA Canada, ERS of ESA Europe, JERS-1 of NASA, Japan, and commercial satellites such as Quickbird of Digital Globe and Ikonos and OrbView 3 of GeoEye. Remote sensing satellites equipped with improved sensor systems are placed in a sun-synchronous orbit with difference in altitude above the Earth. Average altitude is about 900 kilometers. They record imagery of the Earth at different spatial, temporal, and spectral resolution. Landsat is the longest running program for acquiring satellite imageries of the Earth. The program was earlier called as Earth Resource Technology Satellite and was later renamed as Landsat in 1975. Their mission consisted of 8 satellites launched successively. Landsat mission used sun-synchronous near-polar orbits at different altitude for each mission. Landsat satellites typically complete 14 orbits in a day. Landsat 4 and 5 maintain 8 days out of phase, so that when both were operational, 8-day repeat coverage could be maintained. MSS used in a Landsat program employs across-line scanning to generate two-dimensional image. Quickbird has highest resolution, which is followed by Ikonos and OrbView 3. But Landsat and Spot are the most popular group of satellites than others because these satellites are extensively used as they also provide wide spectral range. A group of advanced Earth observation satellites such as RISAT, Radarsat, ERS-1 and 2 and JERS-1 operating in C and L-band frequency of microwaves have been launched. These satellites equipped with active sensors record 24 hours data of the Earth during the day and night, and they also include regions covered by cloud, snow and ice.